through our smart contract NFT gated writing. This is basically a smart contract that I tweaked out of the ballot contract that is available on Remix IDE. And the purpose of this smart contract is to basically allow people to, of course, you don't want to write text on the blockchain. You usually write bytes, numbers, things like that. But this is a pilot smart contracts for our validation purpose. Again, the purpose of these smart contracts is to allow a certain community with a given NFT to be able to write proposals and vote for them. And why should we do it on a smart contract rather than using Google Drive? Well, Google can be hacked. Google can deny access. The owner of a Google document can kick people out. And also, we cannot keep track of the addresses and this sort of financial side of the blockchain. So whenever we have a proposals that have been upvoted to the top, then we can set up other rules or create another smart contract that reward the address of the proposer. So just a quick run through. We have the first announcement of a traditional smart contract, which is the license and Pragma Solidity version. So Solidity version now is between 0.7 and 0.8. We have an import, so we are importing the ERC721 standard from OpenZeppelin, just in order to be able to create our NFT gate. We name the contract NFT gated writing. And then we have two structs. Structs are basically objects from JavaScript language, and they allow us to create a profile. Then we will assign this profile to, in this case, different voters, and assign the proposal profile to all the proposals that can be pushed. So the struct voter has a weight, which is basically a uint, which is a positive number, integer, and is the voting weight, basically. There's a Boolean, meaning true or false, if that person has voted or not. So we keep track of who has already voted and who has not. In case this voter cannot vote, we can delegate its voting power to another address. And of course, there's another uint, and this time is the index of the proposal that this voter has voted for. The proposal struct is made of, in this case, a string. Usually, as I said before, we would probably have bytes 32, and the front-end client, meaning the website, will turn our strings into bytes 32, which is a bit easier for the Ethereum virtual machine to digest. But here is a pilot, a demo that we are building for validation purposes. A vote count, so every proposal has a vote count, meaning how many votes that proposal has collected, and the address of the proposer, which can be interesting once a proposal goes to the top of the vote count and we want to reward these people. And of course, proposal ID. We have a ERC721, which is the NFT address that we want to gate this smart contract to. Modifier is basically a piece of code that we usually attach. You see, this modifier is called has NFT collection, and we can put it in different functions here. What this means is that this function will only work in accordance to what the modifier states. So the modifier basically restricts the usage of a given function to whoever has this NFT. So by typing NFT and using this method, balance of message sender, meaning whoever calls the function, we are stating that whoever calls this function must have at least one of these NFT, the NFT address. Otherwise, that means that you are no member. And yeah, then we have a mapping, which is basically a way to keep, basically to assign to different addresses the struct voter. So my address will have its own template, your address will have its own templates, etc. And we keep that in a mapping called voters. Then all proposals are pushed into an array. So you see that this is the square brackets is the sign of an array, which is basically a list. And in this case, it's a list of structs. So you see that what defines the array is what is before. In this case, we decided to create a list of these struct. And it's called proposals. And then a number, which gives us the current position. So proposal number 1, 2, 3, etc. The constructor is basically a function that runs only once when we deploy the contract. And in this case, we deploy the contract with this function that assigns an NFT address to the contract. So we can reuse the same contract for different NFTs, for example. In this case, yeah, we assign an NFT address to this contract, and we set the current position to 0. There is a function which is register to vote. It is restricted to people with the NFT and basically sets our weight, our voting weight, to 1. Push proposal is again restricted to whoever has our NFT, and it takes a string, so we can, I don't know, which are the most relevant urban areas in our city to start our project from, and I don't know, Berlin. We can say I want to start it in Neukölln, I want to start it in Wittnau, or I want to start it in Tempelhofer Feld, something like this. And basically, this function composes our proposal object and changes the position, moves the position ahead of 1. Delegate function is quite I wouldn't go into this right now, but of course it's mostly JavaScript ball playing to delegate our voting power to an address. And we can go over that if you want to have maybe a one-to-one session. Show proposals is a view function. You see the difference between view function and functions that actually write to the blockchain. This is a function that will write to the blockchain, while this one will just read from the blockchain. So it will not cost any ether in terms of gas. And it will basically return the array of proposals that we stated above, we declared above, which is called proposals. Yeah, so easy as that. How many proposals instead will give us the number, the count of how many proposals we have received so far. Again, is a view function and returns a number. And in this case is the length of this array called proposal. So the number of entries that we have. Vote, again, is a write function because we are changing a number in the proposal object, and is restricted to whoever has the NFT, and we'll set our status to true. So once we have voted, we cannot vote anymore. And also we'll give our vote to a given proposal. Once we deploy this contract, first of all, we have to compile this contract on Remix, and a green mark means it's okay, and then we will deploy it. I will move away from Rinkeby. and move to the local blockchain of Remix and deploy it. And we might have to put an NFT address that right now we'll just copy a random address just to see the functions. All right, it's been deployed and we see read functions and write functions. We see that some functions have a field and some functions have not. So let's go to a function that has a field, vote. For example, vote wants to be fed with a number because this function wants to know what ID, what proposal ID you want to vote for. So it takes 0, 1, 2, 3, 4, whatever the proposal ID is. While register to vote, for example, doesn't take anything. Where is it? Here it is. Register to vote, you see that in the parentheses, in the brackets, there is nothing, while in the vote function takes something. So back to our register to vote doesn't take anything because it just basically set in our address, our own address, to be able to vote. Doesn't need anything else. And these are read functions only. And again, same principle. Some take a clue to work on, and some they just give us whatever they are coded to write. So this is a very superficial overview of the smart contract. Let me know if you want to go any deeper. We can maybe arrange that. Have a nice day. Bye bye.